think you'll come up with this.
So when that person's up to hit right now, what's the probability he doesn't get a hit?
0.7.
Yeah. Everyone agree? Complement rule? 0.7, 0.7D, you can write it 0.7.
You could chop these zeros off if you want.
0.3 is 0.30, 0.7 is 0.7. Don't agree? Complement rule? All right, that's what's missing in this problem. They didn't write that. They didn't talk about that, because here comes the question. Cold streak. What's the probability that here makes an out, find the probability that a hitter makes 10 outs in 10 consecutive at-bats. I'll repeat that, I'll write it on the board. Find the probability that the hitter makes 10 outs in 10 consecutive bats. You and I are going to put that in our own words, right? He's up the plate, out, and gets up the plate another time, out, and out, and out. This is and, isn't it? We're going to multiply these. So we're saying, what's the probability he goes out, 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 out. He just keeps getting out. It's called a cold streak, right? When's he going to break the cold streak? Man, 1, 2, 3, 4, 5, 6, 7. It just keeps. I mean, he's a good hitter, but this sometimes happens. All these probabilities.
So out means like no hit?
No hit.
Okay.
Yeah, and I should be clear about that. Thank you. Probably getting an out in a baseball game, everyone was saying, he's out, or she's out. She didn't get a hit. Right? All right. Or if I decide to hit successfully on base, right? Successfully on base. I probably should have said that because can't they get like a walk? There could be an error and it could reach it. All right, so we're talking about the probability of these what? These outs. This was the no hit. We're saying out. So which probability do we got to multiply to 10 times?
This one.
0.7. I just want you to be careful. Does that mean this?
No.
Sometimes we try to rush it. We're like, no, that's not what it means. We can either do 0.7 and multiply it 10 times, or what's a fast one? 0.7 raised to the 10. Or on your calculator, 0.7 here, 10. And then we'll talk about whether this is, typical, or is this actually something that would be unusual to happen. I mean, he's a decent hitter. Successfully gets on base 30% of the time. I mean, this would be the chances this person has this cold streak. Cold streak, what's the odds?
So that's an unusual.
What do you get?
0.028.
0.028. Everyone has less than 5%. I mean, it's roughly 3%, isn't it? That would be unusual, we could say. That's not usual. Someone in at least one hit. They're that good a hitter. But boy, there's so many factors involved, right? Maybe she, if it's a she, maybe she was injured. Maybe he was injured, right? Something like that.
So and is more binary. Either goes this way or that way.
That's right. That's right. As long as they're independent events. Here's another thing I want to get you thinking. Some of you may argue that maybe they're not really independent events. If you're a real baseball fan, you're thinking about pitcher versus what? Player, and sometimes some players better against this pitcher. Is the pitcher left-handed, right-handed? All that stuff comes into play. So you may make that argument like, I wonder if they're really, truly independent events. Depends on, how you look at it. So if we could say we assume this problem, we assume these events are independent. We'll assume they're independent events. Cool. All right. Edwin, great job at this. The rest of the class, we're going to do 5.4. This is conditional probability. All right. It is what it is. It means probability is based on conditions. So some of you already copied this. If you didn't, go ahead and copy it now. There's a vertical line here. So I'm going to read this from left to right. The probability A occurs given B.
So you mean like B occurs before A?
Yep, I'll say it again, Art, so you go with this. Probability of A given scenario B.
Okay.
What's the probability I die given that I'm a smoker? That kind of stuff, right? B is the event I'm a smoker, A is the event I die, right? What's the probability I die given that I continually drive my car 90 miles per hour down Route 50? You know, that kind of stuff. You know, things like this. But that's the given, so based on a condition, right? And this B event will be that given condition. So when you read it, probably A given B.
Okay, no, you just said it.
Oh, good. And you can always say A given B. The book uses like letters E and F. Might as well just use A and B, right? So that's notation, and this doesn't have an if statement. Do you notice that? There's no like if the events are independent. This thing, that's the true math formula for all events that are conditional. All right. So the first problem I'm going to go to is, this is on page 293. It's in 5.4, conditional probability. I got a frequency table here. Driver, passenger, I'll put down the problem number. This is problem number 19. 19. And you know I teach the midshipmen? Well, the plebes, I got plebes this year, they're all class of 2019. So if the number 19 just happens to come up with class, it's like a loud roar. It's like huge, like 19! Something, you know, it happens like once, you know, every 2 weeks. Number 19. All right, these are male. These are female. These are traffic fatalities. Okay. Traffic fatalities. Okay. The source, everyone, is the National Highway Traffic Safety Administration. Our friend used to work there, actually. 6,450. 11,856. 6,363. I do want to point out that's a frequency table, right, Evelyn? A frequency distribution. We've seen these. And who's got the books? A few of you. I do want to point out there were other numbers given. I want to pretend like they weren't given. That way, nothing scares you, nothing gets you, nothing throws you off. There are other numbers given in this, Michael. Down here and over here and over here to the right and over here to the right, but I'm not going to write them on the board. All right. Letter A. I'm going to read it from the textbook. And then I want you to help me put this in our own words. That's what we got. We just got to be able to communicate this correctly, properly. It makes sense to us. This means probability of A. What's this again?
Given.
Yeah, just see that vertical line? Think the phrase given. Probability of A given B. Or these would be different events. Well, I'm going to read this to you, and it says, letter A, among female fatalities, what's the probability that a randomly selected fatality is the driver? Sometimes you got to reread it a few times. We're going to put it in our own words, though. I'm trying to think if there's a given condition here, right? It was based on one condition. Like, was it all males and females? Let me read this again. Among female fatalities, here's this whole distribution of male and female. Among female fatalities, what's the probability that a randomly selected fatality is the driver? Well, I'm going to put that in my own words. Ready? What's the probability that the fatality is a driver, given that it's a what?
Female.
Female. Does anyone hear that? They said among female drivers. We said, okay, we're only thinking of what? The females, right? Is that what I agree? So you and I are like, I don't even care about this. I don't care about that number or that number. I'm only focused on what?
Female.
All that. So I'm going to write this out. like a probability A given B. What's the probability? The given scenario is that it's a female. Well, let me reread it to you so you know what we put there. They go, among female fatalities, what's the probability that a randomly selected fatality is the driver? So here I get to put what?
Driver.
Driver, or fatality is a driver. You can just put driver. Fatality is the driver, given that it's a female. Now, when you may use that math formula here, but I think a lot of you do this through common sense. I'm being serious. You do this through common sense. Aren't we only looking at these numbers?
Mm-hmm.
Now, it's not on the board, but who thinks they know what the denominator will be?
Total.
The total, the sum of these, right? Right? Here's all the female driver fatalities. Here's all the female passenger fatalities. The total number of female fatalities is this number plus this number, right? Isn't that down here?
Yeah.
All right, so that'd be the total number of female fatalities. So what is this plus this? I'll put the number.
18,219.
So now I'm going to put it down there. When that's this added to this. That's the total number of female fatalities. Driver, passenger combined. That goes down here. Nothing about the males, right? And then what's up here? The
Fatality is
Yeah, what's the number for the driver?
11,856.
Now what's neat, everyone, is do you notice something? I'm not putting probability over probability, am I? Cool. I didn't even look at that formula over here. But what's this formula say? Oh, it's the probability of A and B over probability of B, right? Well, weren't these weren't probabilities, they were just what? Weren't they just numbers? So when I want to point out, we can now extend this formula here and think, well then it's also, because did you see how you and I did this without that? And we didn't even need that. We just logically said total number of females, but in the top we put the drivers that were female, right? Conditional probability. Then if you want, this is interesting, we can write this formula also like this if you prefer. I would. Let n represent number of, because that's what we just did. It's like you and I invented that. Like you can just do the number of these over the number of these. What was the number of fatalities that was a driver? 11,856, right? What was the number that you had to total? 18,219. Hey, what's this come out to be? Yeah, how many total females were there, right?
60.
That's what we're saying here.
About
For a total number of 18,219 females, right?
0.65.
Is that okay with that? Liz, you okay with this?
No.
Oh, now I'm gonna go to the formula, because I did this without the formula. I did it without it, it was just logically you and I saying, okay, we had to look at, the denominator had nothing to do with the males. It would have to be the sum of all the females down here. But in the numerator, we only had to put the ones that were what?
Driver.
That were drivers.
Right, this side makes sense, I'm trying to compare the
Oh, so she wants to use the formula. I'm with you. Ignore the formula if it bugs you, because you make sense of this, but I would like to explain it to you. But I think it'd be easier with this, because we're not going to use P's, because you notice we'll just think number of. So ready? What's A event? What's event A? Fatality is a driver. You go, well, what's B? B event is all females. So what we do is we go, for this number, if I use the formula, I'd be like, okay, I gotta write the number of people in that chart that is driver and a female. I gotta find that in the chart. And then the denominator, I gotta put down the number of all females. So you go, what's the total of all the females? We go, oh, we had to add that. Liz, very good. And then what was the number that were drivers and females? Drivers and a female, 11,000 what? 856. And Liz, I'll be honest, I'm proud. I'm actually happy that you prefer just saying, I understand how to get the answer. That didn't make so much sense. That's common. So I want to ignore that thing if it's bugging you. I'm serious. You're just like, we understand the question, we go into a table. Letter B. Try this one out. What's the problem? Oh, well, let me read the book. And you and I will put it in our own words. Sound good? Among passenger fatalities. Okay, you and I are thinking this now, right? Among passenger fatalities. Okay. Here's your given scenario. Among passenger fatalities, what's the probability a randomly selected fatality is a female? So can I erase letter A? There's letter A. Let me read it again. This is going to be letter B. I don't need that number anymore. Among only the passengers, what's the probability that a randomly selected fatality is a female? Now I'm going to write that like this. They said among the passengers. So guess what's the given scenario?
Passengers.
Passengers. Only the passengers. What's the probability? They said a randomly selected fatality is a female. Okay, fatality is a female. And Liz, let's do it without that form over there. What's the probability fatality is a female? Given that it's a passenger. Given that it's a passenger, it has to be a what? Passenger. We're only looking at what? All passengers. What do you think goes down here in the denominator? I would have to total all the what? Total all passengers. Everyone agree? Which isn't in the table that I didn't put because the book gave it, but I pretend like we didn't know it. You'd have to add these. What do you get?
12,000.
12,816.
Thanks, Liz. That's the denominator one, 12,816, total number of passengers. So total number of those. Oh, I see it in the formula now. Yeah, it's the total number of those. But all passengers. And then, of course, what goes up here? The
Female.
passengers, right? Fatalities that were female. There it is.